Alright, so last time we stopped at the box plot with the regular one, okay, and then the one that shows minimum and maximum. Wow, regular one was this one, okay, based on our data. And you see the far right hand side over here, you see that whisker is finishing at the 1.5 times of the interquartile range, okay. And then you see some extra dots above. What are those? They are extreme values, maximum, and then the next one and the next one. Okay, so that you see the extremes are not included over here, but the next chart over here shows the same one, but the maximum. There is a whisker going on. So it's longer box plot. Anyway, so that's this function over here, range 0. Anyway, so we move down to scatter plots. And then we're going to draw scatter plots between price and miles and another scatter plots between price and year, right? How does the car price, the pickup truck price, I guess it's a used car, right? Uh, differ depending on the year it was produced and then the miles it ran. What do you think? Well, of course, as you see the miles go up, the price goes down, and then the year goes up, which means the more recent ones, the price should be higher, right? The price should be higher for newer ones. But for that part, I'm going to display the graph or scatter plot in two panels in one shot. So for that part, I designate it like this: par m frau, or it's mf row. Okay, 1 comma 2. So let's go like this. All right. Yeah, the price, whatever you showed on your left hand side in your formula over here, or the function over here, should be your dependent variable or your y variable. And then whatever is on your right hand side should be explanatory variable or x variable. So that's why we see some scatter plots like this. You see, as I said before, generally negative relation between price and miles, and positive relation between price and year it was produced. Okay, and then how about log price? Because we took the log, natural log of price. Okay, fine, let's go this way. We see some negative relation, but it's a lot less significant, seems like. Okay, compared to the one before. Yeah, it's less drastic, but it is still a negative correlation that we will be able to find. Anyway, and then price miles, L price. I should have done it. L price. Yes, like this. Okay, so it should be like this: L price and miles. How about L price and year? Okay, so then I will draw it like this. Okay, you see this year and the log of price relation. It seems like it's getting a lot tighter, isn't it? A lot tighter. Right. Okay, than before. If you compare this with the previous one over here, is it less tighter? Oh, maybe my eyes were screwed a little bit. Okay. Over here it's more tighter, right? There it's not that much, but yeah. Okay, so we move down. So that's the scatter plot. But the thing is, the scatter plot, there's a way you can draw a scatter plot by different groups, showing a scatter plot of whole price and then year relations, but showing it in different color dots depending on the car makers. So some car makers will be expensive, clustered around in a higher price range. Some cars may be in a lower price range. That kind of things you can plot it. So color plotting is your homework. Yes. Okay, and then back to lecture note 71. Let's go. 71, where are you? Yes. 71, yes, I want you to draw this kind of thing yourselves. Okay? Tell me the code. And then the scatter plots are fundamental unit of statistics, right? I mean, it's basically just like Carl Friedrich von Gauss' idea of stars, red star, green star, blah, 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 starry, starry night, and then drawing a line, right? There, regression started. And then it's a fundamental, right? A picture is worth 1,000 words, right? If you are able to find and compare meaningful low-dimensional summary statistics, then you are winning the data management game. Okay. So a picture is worth 1,000 words. I said at the first scatter plot, at first correlation table, the relation has to show up. Otherwise, nobody will believe it. Okay, this is one of the rules for top journal publication as well. Okay, the best journals in academia as well, they go for the simplest and fundamental relation between two variables. Okay, and then there in the univariate, we call it univariate setting, one variable against the other variable. And if you find the result, significant result in this scatter plot kind of relations, you have a goal. Otherwise, it's going to be tough. What do I mean by otherwise? Well, some people find this relation, their correlation among two different variables, not in a scatter plot manner, but in a multivariable regressions format. And then it becomes very difficult to convince the readers or the people around you. So you better have this, okay? So that's the key message here. Humans are good at comparing a few variables, and if we can put it in a picture, we can build intuition. Prediction is easy in low dimensions. If you bring it to higher dimensions and then hyperbolic discussions, people will fall asleep and nobody buys it. The key to good graphic is to reduce high dimensional data to a few very informative survey statistics, summary statistics, then plot them. We will focus on information visualization in this course. And then a plot without a concept of variable is useless in graphic. Three broad pillars are there, right? Statistics, design, and language. So statistics means like reducing dimension of your data to a few rich variables for comparison. And it can be just picking two features to scatter plot, or it can involve more complicated projections. That's statistics. And then design is like effective communication, perhaps with shapes and space and color for a given set of variable observations. So how to design it matters. And then, design is a visual communication, I guess. And how to connect it from statistics to design, right? Language, like R or Python kind of things. Make it easy to move from statistics to design, okay? So three elements you need to have, and then they are all interconnected, but we'll be focused on statistics in this semester. And what you see over here is a fancy plot. You see, right? What is it? This is 500 different stocks in the US market, the largest capitalization, about 500, I say. We call it S&P 500 index component stocks. And then from 2000 until 2010, we draw monthly return plots of these 500 different stocks. And you see a beautiful color pattern, which is like a flaming, right? Flaming, or like a heat, right? The core is like a yellowish, and the extreme part is more like a reddish kind of things, right? All different 500 plots are there. Plus one more, two more actually, one more, which is S&P 500 index, which is the average written in, drawn in, solid black line, thick black line. Okay. Well, that's fancy. And then you wish to draw this kind of graph yourself. You're going to do it in this class right now. But wait for that, right? This is fancy plot, that's good, but is that it? Well, what do we learn from it? We learned that the returns tend to bounce around zero. Yeah, it never goes above somewhere like 1 or something. 100% up, right? We don't see that. But actually, one of the things over here tells us that some stocks experienced, okay, in a given month, their return was much more than 100%, right? Over there as well, perhaps 200% or something. Can happen even for the big stocks like S&P 500 stocks, okay? But for average, yeah, it's just bouncing around zero, yeah. And then another thing that we learned is some periods are more volatile and some periods are less volatile. Over here in 2002 or 3, and then the financial crisis period 2009, and we are going to another volatile period. Okay, you don't learn, but okay, you don't learn on this graph why some periods are more volatile than others. We just see that some period is more volatile than others. But what drives the volatility? Okay, only when we learn about the history we realize that, oh, that goes together with the financial crisis. Why some periods, right? When they will occur in the future, we don't know. Okay. It's a beautiful picture, but it's not as much informative as it looks. By the way, welcome to another period of extreme volatility. Yesterday, Nasdaq fall down by 5 percentage point. Thank goodness. Tesla 20% down. Pull out your money, man. Ton of data but little information. Okay. Whereas over here, we see a lot more useful plot. Okay. What do we see? Well, it is a fitting a line between the stock returns and well, this is a fitting of what is it? Beta of a company and alpha of a company. What do you mean alpha and beta? Well, that's CAPM slope coefficient, right? CAPM slope coefficient, beta market risk, and alpha excess return that is not explained by the model. Okay. As long as market is efficient, under CAPM, alpha means your arbitrage opportunity. Okay, free lunch, free money. CAPM based market efficiency says this alpha has to be on average what? 0. But these stocks, right, show positive or negative alpha. So alpha being positive means more arbitrage opportunities, and the minus alpha means like sucks, right? Underperformance, right? You can make some decisions that based on this, right? It shows the stock ticker by ticker, and right. So you can identify arbitrage opportunities and assess market sensitivities. You remember beta? Yes, beta, right? 1, beta being 1 in CAPM means that what? It's as risky as the market on average, right? Bigger than 1, more sensitive to the macro shock. Less than 1, less sensitive to the market shock. And then minus means like it's your insurance kind of things. When market tanks, your stock outperforms, right? Insurance contract, I would say, right? So even you can design a kind of pairs trading. Let's say you narrow down to a similar beta group. Let's say Google and now an Oracle. Now I don't try to find out but the idea is that what? For a given level of beta, similar beta, Why do they have higher alpha versus lower beta, higher alpha versus lower alpha? Higher alpha is a free lunch going on, and then it's more profit-taking opportunities going on. So long higher alpha, and then underperformers, short sell this guy. Why? Based on what? Momentum, right? You can make money out of it. So that's something you can do it using this data analysis, right? And does not have to be a fancy plot, but that's what we do. Yeah. So here you want to project the information in your data into a low dimensional space, low number of variables, smaller number of variables, I should say. Space that contains key insights for the decisions you need to make. Bring your messy data into useful information. That is what data science is about, especially in finance. You need this kind of things very much. By the way, if you want to write mathematics like beta and alpha, all these kind of things on PowerPoint or words like LaTeX, or what we see in LaTeX, right? Then watch my another YouTube class about it that I recorded last semester in international finance. Go ahead and do it. It is very convenient once you get the hang of it. So you don't need to click and punch everything like that, but just you can use it like what you do in LaTeX. Yeah.
I'm Andy Kim, and today's lecture, I just prepared a short instruction for non-engineers about how to type mathematics using Microsoft Office, PowerPoint, or Word, right? So PPTX or DOCX kind of format, right? That's your usual MS Office, right? But how do we type such thing as this one? Do you see this formula? This is what? Do you remember?
You can learn how to do it in your free time. Good. And then you can learn how to pronounce those Greeks. Alpha, beta, gamma. Oh, yeah. Then let's go to the R codings. Yes, let's finish textbook page 15. Okay, page 15. Here we're gonna draw those fancy graph, okay, of S&P 500 that you remember that, right? This guy, right? We're gonna draw that one, and then move down to this one, similar to this one, not color-coded one, but with some special feature. You will see it. So see, let's finish textbook, running a regression, but the result would be stored in what? A data set called fit. So wait, before we move down to S&P 500, here is another thing. Based on the trucks data, okay, trucks price and mileage and year, all these kind of things. Let's finish the discussion, coding, and then move down to S&P 500. So running a regression works like this. Here, look at this GLM, okay, generalized linear model, okay, and then parentheses, you start with the dependent variable, your vertical axis variable, y variable, and then tilde, okay, tilde, and then a set of your explanatory variables or right hand side variables. So maker, and miles you ran, and then the year, so plus you connect it, and then specify the data set, which is trucks this time. Okay, so run it. I did it, but no result showing up. Hey, what the heck, Andy, come on. But what did I do? I set all those results in the regression. Okay, regression table will be generated, but that table should be something like a matrix. So I'm just going to put it into a fit data set, a matrix called fit. So let's just click this fit. Okay, the regression results are here, the coefficients. I can punch it, right, like this, the arrow down and side. So coefficients, and then you see intercept, the regression intercept, and then the coefficient of each variables. Make GMC. What the heck is that? That's dummy variable, because this is the maker variable that is character, okay, character type. So each character type will have a dummy variable of 1 versus 0, 1 0 1 0. Okay, quite convenient. You don't need to create any more dummy variable for this part. Then miles and year, right? So those are explanatory variables, and you see coefficients for each. So intercept is this, and then the others are like that. Okay, good. And then the residuals, okay, 1 2 3 4 all the way down to 46. Now fitted values, okay, fitted values is like what is it? Excluding residuals. So your dependent variable, stick it in and multiply it by each coefficients plus intercept. That's it. That's the fitted value, predicted value by this regression formula. Okay, the values on that regression line or regression hyperplane in this case. Okay, regression hyperplane. And then the residuals, the discrepancy is the residual. It's not on that fitted values, but this residual. And then the effect, yeah, all these things, right? We can discuss it later. And then you see a lot of information going on, right? We're going to learn about that later. But the important thing is this result is stuck it into a matrix, a data set, fit. So I want the summary of fit over here. Yeah, and then the summary says, throws out like this, deviance, residuals, blah, blah, blah. And then all those regression results are showing up. Coefficient estimates, yes, for each explanatory variables, including intercept. And then standard error, and then t-statistics. What is this? T-statistic? Well, that's estimate divided by standard error. That's t-stat. And then you remember those t-stat, t-test distribution, right? Which converges to normal distribution. And then based on that, you get the p-value, right? Depending on the degrees of freedom and blah, blah, blah. But you know that, right? The tail probability. We're going to talk about this p-value thing soon. And then you see what? Some variables show very, very, very significant statistical results, like the last two, miles and year. Forget about the intercept for now. All these things, stars show significance, statistical significance at 1% level, and then 0.1% level, things like that. Okay, you see a lot of stars, you have a goal usually, right? But part of it is data mining, so you have to be careful. The items that you see later, we're going to study in the future. So that's regression that we typically do. Okay, so AIC or whatever, let's wait until a couple of weeks later. Now, you want to replicate page 1 of textbook, which is the S&P 500 stock return graph, right? And then alpha, beta graph. We will go there from now. So for this purpose, okay, we play with stocks.csv file, okay, stocks.csv file. Every now and then you need to install some packages in R, and then you need to explore Google. But for this part, you need to install packages like TIDYR and DPLYR. Don't ask me what this is about, but seems like this is one of the most important packages working in the stock market analysis. Okay, so install that packages, run it. And then it says this message to me because I already installed it. Do you want to restart R prior to reinstalling? Maybe not. Maybe not. Okay, fine. But you have to click yes because you did not install it before. But once you install the packages, then you can go, but that's not the end. You have to retrieve it. Okay, it's installed in your computer, but you have to call it. That's library function over here, library command. So run it, and then it is ready to play with this package. Right. Sometimes some of the libraries don't get installed. I told you about this. Okay. Some of it did not work in my other computer, supposedly better computer, and it doesn't work. Okay. But we'll go there. And then we have to import that stock CSV file. Okay. Stock CSV file. Open up the data set and check out the variables. Okay, fine. So import it. Okay, where did I place my stock CSV? As I said before, it has to be in my C data R. C data R. You see that over here, and then stocks over there. Okay, so if I open this guy, nah, I cannot. It's the size is 44 megabytes. So if I try to open it in Excel, it will screw up my computer maybe. But we can try another one. Okay, just T-bills, and then it opens up. Yeah, T-bill is like a U.S. Treasury return, risk-free rate, day by day over here, and then it is shown in Excel in nice way. This is actually month by month, okay? Captured at the beginning of the month, right? Whether it should be beginning of the month or end of the month does not matter that much, okay? It's gonna be similar results anyway in a big data. And then do what? Well, you got stocks over here. Hey, wait a minute. Did I? Yeah, because it is in my working directory, right? WD, working directory. I just can write it this way. Read.csv and then quotation stocks CSV. Okay? Voila, we have stocks. Click it and then open it. Make it your habit. Each time you create a data, click it and open it and see it and eyeball those things. Okay? Why? I see many PhD students or other researchers have this kind of attitude. Oh, those dirty data, you import it. I will create, my genius brain will create a perfect code, so much so that I can work it out without even looking at the data once. But I say, screw you, man. I say, you don't know what's gonna happen to your data each step you perform a certain command. I experienced so many, places to make a correction or deal with the dirty stuff, right? You have to get used to that, right? That's what data science is about. The first step, okay? It's a dirty step that you have to master, right? So each time, make sure you open it up. And even until now, I'm still doing that, right? I don't trust the SAS, or I don't trust the coding, because when in the process of importing, a lot of screwy things happen. For example, previously in the CSV format, something may have been numerical data, number format over there, but as I import it into R or SAS or Python, that numerical data switches to become like character variable, so that when you run a regression or summary statistics, the computer gets screwed and say what? This is a character, I cannot give you any results. But if that is the case, if that happens, then your supposedly perfect code is going to be screwed up altogether, right? You spent weeks building your code and you wasted your time. It becomes like that. So each time you import or do some data step by step, ooh baby, you have to open and see, okay? Make sure everything is correct. That is tough. That is tough. Especially under the social pressure of, other data guys not doing it and then despising this kind of things, right? You have to do it. Okay, opening up, what do we have? Date, ticker, that is ticker symbol, which is what? 종목 code in Korean terminology. And the interesting thing is, in the US, those tickers are alphabetic, whereas in Korean it is all numeric, right? 005930 삼성전자, right? But here it's like a Oracle, ORCL, right? And then div AMT, what is that? Well, that is, to my eyes, it looks like that's dividend amount, okay? How am I supposed to know that? Well, only the experience will tell you, okay? 짬밥 matters over there. Okay, fine. PRC, that's not China, okay? But it's price, okay? Price. And RET, that is return, okay? Having seen dividend and price and return, you may wonder whether this dividend is included in this return calculation, okay? Because dividend is a cash return, and then the change in price is cap gains return. For every return, you have two components, cap gain returns and dividend returns, cash returns. So those return calculation is nicely done for you, but you have to suspect, right? Does this return include dividend or excluding dividend, right? My bet is that it is including dividend because it is number one, American data, crisp CompuStat kind of things, always included, RET. And number two, you can check it. You can, I'm sure it is because you have a variable called RETX. Return X means excluding something. What would you be excluding? And then pretty much you can guess it with your 짬밥, and then it's like an experience, and it must be excluding dividend. So you can check your guesses or intuitions for the observations over here on observation 9, right? Number 9, Oracle, they paid out dividend 5 cents per share, and then that is excluded in the price, so that if you compute a return purely based on price, okay, purely based on price, the return will be this guy, 2.17%. But including 5 cents of dividend, the return will be this guy, 2.379%. Okay, so RET, thank God, it is including return. For finance research, which one do we need? Return excluding dividend or including dividend? Obviously, it has to be including dividend, okay? That's one thing to notice. And another thing to talk about is PRC, price, right? Why? Because there are a lot of stock splits that you're going to be bothered, okay? Stock splits. What the heck, you may say? Where the number of shares outstanding multiplies. That means your price per share halves or like shrinks down like crazy, even though your market cap does not change significantly. Okay? Some of you may wonder, doesn't that stock split increase the market value because somehow the more traders are buying and selling and blah blah blah. Forget about it for now. Okay, that can happen, but empirical research suggests that it's not. Okay, on average, it's not. Okay, if we are just splitting the same pie with more numbers to cut. Okay, So the total pie size does not increase significantly. But the thing is, over here, the study with this price number over here. Okay? So stock split, 2-for-1 split, right? Used to be one stock and now it's two stocks. So the price will be half, right? Does this price reflect that kind of stock split? Is a valid question. Okay? And the United States data, they adjust for this stock split so that you don't have to worry about it. Well, that's good. But then, what's the problem with why did I say this? Whenever you work with the data in other countries like Korea, China, Japan, or whatever European countries you may wonder, make sure those prices are adjusted. ADJ, right? When you pull out the data in Yahoo Finance or something, you will always find the price column with adjusted something. Okay, that adjustment is for this stock split as well as those dividend payout. Okay, dividend payout. Why? Always those dividend, right? Dividend payment results in what? Dividend, ex dividend price, 배당락 kind of things, right? You want to adjust it back, okay, as much as the dividend is concerned. So working with that adjusted price gives you the return correctly. Over here, RET, that's the one we want to work with. RETX, forget it. SPRTRN, what is that? You can guess it. S&P return, S&P 500 index return. Thank you. Yes, that's it. So we have those columns, and then there will be a concern about missing values. For example, div amount. Well, most of the dividend payment amount will be missing, NA it says, right? Because you don't pay dividend every day, right? Once per year or once per quarter, like that. So that's why. But you will see some missing values for each and every one of these variables. That's what makes your data analysis very tedious, and then 노가다, like yeah. So you have to be careful. We're going to go through that part, and you can scroll it down to check the number of data, number of observations, and all these things. Okay, fine. 901.11, that's number of observations over here at the first stage, and you can check it with this over here. Right, 7 variables over here. Okay, Andy, do you really have to see that matrix like that? That's paining me in my eyes, but that's a part of our lives, okay? If you don't like it, you can always choose not to work it. Length, what was that? The number of columns. And then n row is the number of observations. So you can check it like this, like that. Yes. Okay, you need to work with RET, yeah, but need to check if the variable is correctly recognized as numbers. Those return. In my eyes, in your eyes, this is really a number over here. But is it really the number as the computer imported and then the computer recognizes as a number so that they can add and subtract and take the average or whatever they want, or whatever it wants? It may not. So we need to check, okay? So many times the variables are misclassified as characters. In such a case, you need to switch it back to numerical variable. Otherwise, you cannot do any mathematical computation based on it. So, number 2, another thing that I tell you associated with it is that do your data work as soon as possible. Don't wait until the last moment, believing that, oh yeah, I'm gonna just mastermind all of these things, and just once I click and once I punch in the run, and you will automatically just import those unknown data into my computer and then work out nicely, pyong, over there. No, right? It's just a pain in the eyes, right? So exam setting as well. Don't wait until the last moment. All right, it's gonna kill you. So work out always, right? from the beginning. Okay, just living with the data. Yeah. And then in such a case, yes, do any mathematical computation based on it. Yes, summary, yeah, is a nice way of doing it. So summary of this matrix gives us an idea about the class of these variables. So we have date, ticker, dividend, and then price, return, return X, SPRTRN. Which variables are character variables and which are numerical? Character variables, ticker, yes, it is character. But you see return and return X. What did he say? Character. Character. I told you, right? Things happen, right? It happens. Price, yeah, it is numerical. How do I know that it is character variable? Return, you see class character. Yeah, return X as well, class character. Holy cow. The rest of the guys are okay. So we have to do something about return. Return X, forget it. We're not going to play with this one. Date is an important one, okay, for various reasons, okay. This is another one that screws your mind too much, all right. Whenever you import data, you have to make sure about this one. It's very painful. I tell you right now. This has to be recognized as date value, date category, or date class, I should say, by the computers, not by you, but by the computer, right? Voila, okay. So let's see. We can check one whole matrix like this with summary, or you can check one by one the variables, right? Yeah. Date should be recognized as date format. Why is it important? Well, for example, January effect kind of things in your stock market. You want to classify the date into January period, February period, and then if the computer recognizes it as date, it will automatically classify for you. Otherwise, you're going to be like wasting your so much time, right? Weekday effect, right? All these kind of things. Very handy once you learn it. But always suspect that those format may not be recognized as it should be. So that's that. Summary of one variable, yeah, and then it says class character. Come on. When do we have missing values in stock returns? Open up the data and see. Right. So misclassification is one problem, and the other is missing values. Right. Missing value. 공란. Right. 공백. Correct transformation from character to numeric is the following. You will see it return. Okay. But before that, I said missing values. So let's open up the stock data, and then perhaps I could do what? Sort. Okay, sort the data by return. As I click it, you don't see any movement, which means the computer is busily sorting inside. That does not show you. Okay, but I'm not wasting your time, hopefully. But let's wait until the return comes out. Until that moment, can we pull it out somewhere? No. Yeah, it did it. Right, it did. All right, good. 44 megabytes, so it doesn't take too long. You see return empty. That's missing value. You're in trouble, man. You cannot run regressions when it is missing. And then if you scroll down, you will see those returns are missing until this part, and then goes minus 0.00000 return. Okay, interesting. Daily return. These are daily returns. Okay, and then you can scroll down and then sort it with PRC. You see 32.49. I don't know. Not that a return. That's the return. Here is another kind of missing value for return, RET, right? You see B or C, okay? B or C, that comes from CRISP data management rule. Some part of it, I mean, I don't memorize all these missing code, but there are some cases, for example, when the company first launches in the stock market IPO, right? IPO. The first day return should be recognized somewhere, but purely based on previous day's pricing, the return will be missing because yesterday there was no price in the market, and then you have today's first price, IPO price, end of the market IPO price. So the first day return will be like missing, even though it is huge. Okay. So that may be why. Another thing is when the company gets delisted, okay, that gets delisted from the stock market. When the company gets delisted, you're in trouble. The company may be going bankrupt or something like that, or there was some fraud going on. Your stock used to be $10 per share. Today, there's no stock for you. What's the return? Missing. Okay, so that could be another reason why. There are many reasons that leads you to missing values in returns. This kind of things you have to clear up before you do analysis, okay? Korean data, how clean is it? I don't know, okay? The rule of SKKU's tenure procedure is like work with top journals or worldly recognized journals, and those journals don't look at Korean data that much. So that's why I'm more used to American data rather than Korean data, which is kind of funny right now. But I'm getting back to that one. So let's see. Return, yeah, the missing. We have to eliminate those. And price is also the same thing. Sometimes price is missing. PRC, yeah, for various reasons. And then the ticker symbols, you will see that ticker symbols are also sometimes missing. Sorting it by ticker. By the way, sorting it by return, the missing values are treated as a small number so that it goes on top when you sort it. Depending on the software or language, those missing values can be treated just like smallest number like this, or some software treated like a biggest number, something like that. So be careful. And the ticker symbol, you see empty spaces over here, right? There are sometimes the tickers are missing, which is kind of silly, you would say. But it happens. Sometimes the company changes its ticker. Okay, right? Sometimes it happens. When it switches, yeah, there are some missing codes. I'm going to give you some missing codes later on from the manual of CRISP, CRSP, so that you can go through for your reading pleasure. But those missing values you'll have to eliminate, right? Drop out. Okay. Okay, so first of all, the concern was about what? Character value. Okay, those return was recognized as character. Now we want to switch it into numerical. So that's this as dot numeric function. Okay, and then the objective object variable is return stocks data. And then in the middle, you have to recognize it. This is a character variable. So that's why we have as character. And then switch it into numeric finally. Okay? Once you switch it, I want you to store it into a vector called return 1, which is outside of stocks data, just for your pedagogical purpose. Just let's see. Okay, it says warning. And then you force the changes. And then there are some NAs, what is it? Missing values, right? So let's see the summary of return 1. Here you see on the right hand side return 1, right? we can I don't know, drop down menu, but that's pretty much it. Large numerical values going on. Switch it back. Summary, right? Over here it says minimum, maximum, and the number of NAs or missings, right? 3,391 observations, missing returns. This is non-trivial. Come on, right? So many of them missing. Oh, right. That's the most developed capital market in the whole world. You see this kind of missing value problems, which is, ubiquitous everywhere. Good. Now, here, but the following seems to work as well. Just as numeric variable, and then created a variable called return to, summary like this, the same results over here, right? And then anyway, this time I'm just going to stick in those, change the format into numeric and then switch it into the existing variable called the RET, the return. So that's this command, okay? Another thing that will constantly bother you is the format of the date. Let's check the format of the date variable, okay? Okay, class date over here. It says what? Integer, 정수. What? Why do I say what? It has to be date format, okay? To recognize something like Monday, Tuesday, Wednesday, Friday, the date computation should work. But if it is recognized as integer, you're in trouble, okay? If it is recognized as character, you are in more trouble because you have to switch it into integer and then into date format. But here, rather luckily, it is recognized as integer. So it is, okay, we need to switch, like this. Format, %y, %m, and %d is the one you need, okay? So as date is the command. And then it says as character, okay? And then stock date, okay? Why didn't you integer? Well, say integer over here. Well, that the textbook author said character over here, so that's why. You can try with integer, but I remember that did not work. Anyway, so work with this, and then create a variable called date1, which is going to be outside the matrix. Okay, it's not in the matrix, but I'm creating a new variable outside. So date over here. Yeah. So if I then class date1 forces the computer to tell the format of this date 1. That's date. Now you're ready. So for this one, I do it again. So that switch the date in the stocks data, change the format, and then stick it in, overwrite on the date variable like this. Okay, check the class of date variable again, like this. Oops. Why does it say function? That's because I forgot to type stocks dollar last name. What family do you belong to? Okay. Open the stock data. Okay, fine. Stocks data. Okay. Good. Like this. Over here. Alright. Check it. And then now you want to filter out some of the observations like missing value. You want to drop those observations where return is missing or whatever is missing. Okay. Sometimes the companies in the US change tickers, sometimes ticker missing subsequently. When ticker is missing, return is also missing. Sometimes return is missing for other reasons. Here, okay, here I use this function filter, and then the condition is when ticker is missing, okay, and then the return is missing, okay, And then once you filter out the stacks, I will create the once the missing value is reduced, that missing value reduction will result in new matrix name called stacks2. Why do I do that? Just for your pedagogical purpose, to show you. The stacks over here, see that number of observations over there? And then I'm going to create stacks2 right underneath. Okay, now you see the number of observations reduced like this. Number of observations 3,000 or more has reduced, and then 7 variables, right? Yeah, you can compare that. For that reason, I just created another one. But for this code of replicating, I'm just going to now replace the stacks with the missing value removed one. Filter out duplicate observations. Another concern with this, okay, data management, is that duplicate observation, 중복 출현 kind of things may happen. Why? Because those guys who is recording those data can make some stupid mistakes. It could be you and me, it could be anybody, right? I tell my RAs to collect this and that data. They diligently work hard like crazy. 24/7 work. What happens? Get tired. Their eyes like a dark circle. And then punch in. And then they repeatedly punch in the same thing in the next row sometimes. And then sleepy. And then the thing is like, screwed up. So duplicate observations we want to eliminate. Oh, come on, Andy. It's over here. The computer must have recorded all those things. But sometimes those system managers, you never know what's going to happen there. So we want to make sure each company, which is ticker, have one return observation per date. No 2 return observation for the single day, for a single company. So this command says eliminate duplicate observations. Okay. And then first of all, identify those duplicates with dupes variable. And then you eliminate those duplicates. This is dupes, like whenever dupes is identified, duplicate is identified, minus dupes over here is like take out, right? Take out those duplicate observations. Yeah. All right. So if you compare stacks, dupes, one, you see this console panel. Only when the command is done, you see the cursor blinking, coming up. Okay. Now you see stacks and stacks2. Now stacks has 30 less observations than before, right? So duplicate observations were there. Come on. S&P 500 data. Still happens. Okay. Notice it is a daily data and we want monthly return chart. Okay, you want to get monthly return. What do you do with this? Here, just to check, right? It's just for a single Oracle stock, day by day return is here. And then the chart that you want to draw is monthly returns, right? Monthly returns. How would you do that? Well, based on daily data, we want to, compound the return. Okay, I want to calculate the compounded return. How do we do that? Well, this operation over here, we want to do it over here. You see this? We call it the product, right? Cumulative multiplication is called the product, right? Cumulative sum, we represent it by sigma is sum, right? Cumulative multiplication called product, we represent it by some Greek called pi. 3.1416. Yeah, that pi, right? But Greek p is pi, so this is the one pi. And we need to specify from which time point to what time point. That t has to be from 1 to t, maybe 1 month, right? In a given any given month, whatever day it may be, trading days, maybe 22 trading days or something like that every month. You don't need to specify that, but we're going to construct a product for a given month, right? How many days it comes, it doesn't matter, just for a single month, just product it, okay? But before making a product, you may want to make sure the return is 1 plus return, because otherwise those daily return will be less than 1, and then the product of some less than 1 values converges to 0, end up nothing, okay? The return concept is like 1 plus, okay? So you have to compound it, 1 plus return multiplied by another. And then at the end, what you have to do, subtract 1. Don't forget this part. People get awfully confused when they compute this product. And that product function, we're going to create one called the function r, and then product like this, okay? Defined as product function, and then sorry, did I say? We are going to create a function called ag, right? AGG, aggregated product, okay? AGG will be a function, right? So that's what we're going to do. Let's check back over here. Right. Yeah, monthly return. For that part, we need to classify. We need to group the daily returns into month by month return, or month by month group, right? So we need to identify those months. Okay, we want to create a variable called month, but it's not going to be like January 1 and then December 12 kind of variable, but it's going to be another one. I'm going to show you, okay? Yeah, check out the data in the second stage, right? So let's run it and then wait a little bit, and then it shows like that. Month is created on your far right hand side over here, right? And you see it's not just January, but it's like a beginning of the month, right? First of every month. The date value is specified over here. Oh, I'm in trouble, It is just a date, not month. Even though the variable says month. Come on, it's okay. It's just for a given month, you have a common value there, so you can just group it based on this. So don't panic, it's okay. And then for you need to run aggregate function, okay? Aggregate function, you build it, and then -1, right? And then for each given ticker and month, by ticker, by month, right? By ticker, by month subgroup, right? We're going to use aggregate function to get the monthly return, okay? So that's return aggregation, and then we are going to also do the same for S&P returns, right? The index return. The interesting thing is over here, S&P return is shown for each stock, okay? For each day. That means you have 500 different stocks, and S&P 500 index is just one. And then it shows up again and again and again and again 500 different times, okay? So you can think of it that way. Yeah. Anyway, so each month we're going to aggregate those return in S&P 500 and create monthly, right? and you see monthly, da, 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 yeah, summarize, monthly, right, over here. A data set called monthly, MNTHLY, has been created. Okay, and this data has what? Ticker starting from A, and then month, each month you see it, and each month's monthly return is shown over here, and then S&P 500 index return over that month is there kindly for you. Okay, so that's that. And then we need to generate a time series monthly return for the S&P 500 over the identical sample period. So return, okay, as data frame monthly, and then -4. Well, spread and ticker return. What do we do? Well, this is eliminate the rightmost column from monthly, and then spread across different stocks on each given date. Okay, and then check out the return data. It has more than 500 stocks. So return data will be, let's run it and see what it is like. Okay, definitely starting from monthly and then square bracket comma -4 means the fourth column should be dropped. Okay, then it's going to be spreading those ticker symbol and the return. Okay, the date is common, but it's going to be spreading out like that. So we created the return data, RET. Let's check it. It has 84 observations and 549 variables. All right, so if you scroll it down, okay, you have 84 variables starting from 2010 January, finishing in December 2016. Makes sense? And then if you scroll to the right, you start from A, AA, AAA, AAP, AAPL. That's Apple. Okay? That's Apple, by the way. And then scroll it, and it goes down to so many different stocks. It stops somewhere A, but the computer is tired, so that it stopped. Okay, so you have to recognize that, at the end it's going to be like something Z. You're going to see it. Those return are spread out, the spread function. Okay, it's going to be very useful later on. Okay, and then what do? S&P return. We're going to create a matrix called S&P. Okay, why? Because we're going to draw a chart based on this 549 stocks and then S&P return, the black line, you see it. So S&P, we create that S&P like this, right? Months and S&P. Good. Then going backward over here, S&P 500. Okay, S&P stocks. How many different stocks? It says RET has 549 variables. Why isn't it 500? Well, guess what? Some of the stocks get into S&P 500. Some of the stocks drop out of S&P. Recently, Tesla was about to get into that S&P 500 because their market cap was so much increasing, but they failed, right? Some companies successfully get in. That means some companies inside that index drop out. So that's why over time, right, we're going to have more than 500 companies in this sample, right? Okay, now S&P return, and then the next one, remove duplicate observations from S&P. Okay, so S&P, because you see S&P data, it is repeating 549 times, right? So just shrink down to non-duplicate, and you see S&P observations is now 84. Okay, that's good. And then Now get ready. Prepare for drawing a chart. You're drawing a chart. All right. You need a time grid on the horizontal axis. So D grid has to be set up as a variable, which is going to be date. And then the date value, you just specify it. 2010, 11, 12, all the way down to 2017. Okay, fine. D grid has to be generated, and then the generated vector is shown down over there. Okay, and then return mped has to be selected. This is some mped. It's a one company's return as an example, right? It is kind of petroleum company stock. It's just extracting from return data, right? So this one is mped's data. Now, right. Somehow the textbook author excluded mped data to show this graph. I don't see why it has to be extracted. You can just keep it, I guess. But let's follow the author. Right. Fine. So now you are ready to draw those 549 stock price chart and return chart, okay, together with S&P 500. One more thing you need is risk-free return over the same period, and that will come from T-bills data CSV. Okay, make sure it is in the right folder, and then yeah, T-bills I showed you before. Import it, read CSV, and then make sure the date is in the right format, and lo and behold, character value, that's, we are in trouble. So we have to switch it into date format as date. Now like this, you check it, it is date format. Now it's time to draw some graphs in one panel. Okay, so I set PAR MF row C 1 by 1. Okay, set the margin of this graph par MAI. This is for margin setting. Bottom left up right, bottom left up right, like inches by inches, right? You specify 0.6, 0.811 in that order. And then matplot. This is a function to draw graph. Okay, and then here I don't know too much about this graph function, but here's are some interesting stuff. Return, okay, return will be shown in the y-axis starting from maximum 1, minimum -1. There will be grid, okay, and then x label, y label. Y label will be returned, okay, and then BTYN, you can search for that in Google. It's a format of the table, the chart format kind of things. Type will be line graph, and then here's an interesting thing. Color, COL, right? Should be what? Is it yellow, green, or whatever? It says heat, and colors 24. So 24 different ranges of heat-related color. You remember that yellowish to reddish thing? Yes, close to heat idea. Oh, we can make it more beautiful then, like that. Maybe you can generate a graph on the green range, right? I don't know. Go ahead and find out, right? And then other functions you can just study yourself. Google it. And then axis as numeric and labels down there, right? Axis. So let's run it, and then I have to get away. Sorry. Yeah. So you see this, right? Beautiful chart. Flaming, right? That's because we have heat over here. Can we see mountain here over here? I don't know. What if we replace it with some ice cold something? Anyway, lines and T-bills and S&P, you can punch in, yeah, and overwrite it, okay? T-bills in color 8, some color 8, you have to find out some, I don't know what kind of color that is, but that's overwriting. And then we need some legend for the graph, S&P 500, and it shows like this, okay? So you did it, yeah! Have some sense of achievement, 성취감 만세, right? So that's that. Here you want to, this is your first graph that you generated. So what do? Copy to the clipboard and say, copy plot, and then take it to your, yeah, over here. And then Andy's first graph of S&P 500 stocks monthly return. 500 different, have you ever drawn 500 different line graphs, right? And that 550, right? Must be your first time. For me, it is my first time. Okay, fine. So that's what we do. Okay, for textbook page 1, right? The next one is the alpha beta graph, right? Alpha beta graph. Figure 1.3. Let's do it. Why not? There you need a CAPM regression beta, horizontal axis beta, vertical axis alpha. For that part, you need many regressions, CAPM regressions. For here, we are not going to run a regression of 500 different stocks, but only some big 25 stocks. Okay, so here you see big stocks data in your R what is it? The folder over here. So CSV ready. So import it into R, and then in the name of Bigs. Okay, Bigs. Then open it up every step. Here, you have only V1 and V2. Didn't specify the name of it. Okay, fine. And then Apple, Google, Microsoft, all those market cap based ranking, all the way down to 25 stocks. Okay, 25 stocks. Fine. Okay. And then header false means like there's no variable name. Okay, no variable name. What do you mean? Well, let's open up just for fun over here, CSV folder, file. And you see the first row over here, number 1. Is it a variable name? No, it is already a value. There is no variable name in this file. In contrast, the T-bills, right? You had variable names over here, date, and then returns like this, specifying it. Okay, so that's why if you don't have variable names in your first row, you have to say it like this: false header is not there. If you don't say it, the computer will recognize AAPL as variable name. You're in trouble. Now, so that's that. Here, to run a CAPM regression, what do you want? Well, you need excess return, right? Excess return of your stock and excess return of market index return. In excess of what? Risk-free return. Remember that? All finance research is about the risk premium, which is excess return, right? Excess return. We try to understand our company's excess return with respect to market excess return. Okay, excess, common, right? So create excess return variable. It's a matrix, by the way. Sorry, a matrix. Excess return, but this is going to be an excess. The matrix by matrix to what is that? Matrix computation. Okay, for each row of the matrix called RET, you remember that return 549 columns, right? You want to subtract the TBL rates for each and every columns for the same month, right, like that. So that's what's going on. Okay, as matrix, okay, this return, okay, and then take that row column, right. What is it? Here, return, and then look at the big, okay, bigs, right? Look at the bigs data over here, which is the stock name V1. The first column has a stock name of it, right? So for those companies in the big, for those 25 companies in the big list, pick out those things, those returns in the monthly return from return data, and then subtract the TBL return, okay, TBL rate month by month, and then create XR the matrix, okay. So XR, this excess return, is this guy. You see Apple, Google, Microsoft, and Amazon, blah 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 blah, like this. Yes, month by month. Here you don't have the date variable. We just created one, the access return data, and then hopefully the date order did not change. Okay, extract monthly return of this. Yeah. So then get the excess return. Now you have excess return on one side, and then excess return of the S&P 500 index. So that's gonna be MKT data set. MKT. That's gonna be one column vector, so it's not necessarily matrix over there. Good. So CAPM, right? With this excess return matrix and then MKT excess return on the market index, we're going to run CAPM regressions, matrix by matrix regressions. So column by column of excess return, okay? Column by column of excess return over here, AXR. One column Apple, we obtain CAPM result. Google, we obtain CAPM result. Facebook, we also do it. So 25 different times we're going to have it, and then create the result as a matrix called the CAPM. So we have CAPM over here, and the result shows like this. Okay, and then the coefficients and all these things, residuals are shown, right? Unfortunately, it does not show the precise matrix of it, but you can play with it, right? You can just click and see what's going on later. And then what we want to get is the alpha and beta coefficient. So we're gonna see, right, we're gonna use this T function and says coefficient, scrap the coefficient from CAPM results, right? T and then 2 to 1, okay? It's like out of the regression results, extract the alpha and beta, okay? So these AB, alpha beta variable will look like this over here. All right, MKT, that must be beta coefficient, and intercept must be alpha. Okay, fine. We're going there. Good. And then plot alpha and beta. Here, yeah, par mai is like what? Margin. Bottom left, up, right. Okay. Plot AB. Okay. And then X lab has to be beta, and then Y label has to be alpha. And then AB line has to be drawn. Okay, AB line V1 and horizontal with a H0, 8. And then let's do it. Display the company with its ticker symbols. Yeah. But until now, right, if you run it, the result will look like this. Oh, disappointing. Holy cow. Nothing shows up. But don't worry. Here, you run it and it shows with the font of the Google or AAPL kind of ticker symbol. The size of it reflects the relative size difference, market cap difference of each and every different companies, right? Now, here, if you want to, okay, get rid of number nine's observation, okay, ninth biggest market cap company over here, which is Walmart. If you do it, and then the Walmart is over here, take a look at this, and then pay attention, and then let's see what happens if we run it. Walmart disappeared, right? So that's another thing we want to check out. Yeah. So that's basically it. Okay. Once you do it, don't copy over here. It just does not, work out like this. Export it, copy it in the clipboard, and then my second picture. Copy plot, and then in your Word file, go down. Voila, it works. Okay, so keep it as a souvenir, right? Then let's see. Gotta shrink down. And then, all right. All right, stock return charting. Yes, we did that. Okay. All right. So the next part I'm going to talk in the next video. Thank you.